So, hello guys, welcome back to Educational Minds Hub. Today we're going to be talking about exponents and roots. So an exponent, you'll see, traditionally, looks like this. Like, let's imagine you have some x to the third power. So that would be an exponent here. And basically, actually before I get into it, this x is actually called a base. Whoops. That's base. And then this thing, this 3 over here, is our exponent. And what this exponent basically tells you to do, it essentially tells you to take the base and multiply that many times. So if we have x to the third power, or to the third, so this 3 tells you, this exponent of a 3 tells you to multiply this x 3 times. So x times x times x. And let's look at another example. Let's say we have 3 to the second. So a common misconception of these exponents is people tend to think, oh, this is just 3 times 2. And I would tell you that that is one of the most incorrect assumptions you'll ever see. Because 3 to the second power does not, I strictly say, does not equal 3 times 2. Instead, this 2 tells you to raise, so let me appropriately label these. That 3 is a base. That's a horrible arrow. That 3 is a base, just like that x was. And then this 2 is an exponent. So the exponent is 2 and the base is 3. So that tells you that that you have to multiply the base 3 2 times, because the exponent is 2. So it tells you to multiply the base 2 times. And if this was a 3 here, if that was a 3, then it would be telling you to multiply the base 3 times, so we'd have another 3 here. And then we can simplify this to 3 times 3 times 3, which is 27. Now that you are familiar to what an exponent is, let's go over some of the properties of exponents. So the first property of exponents is, this first one is common sense. Anything to the first power is just the same base. And then the second property, let's say you have x to the a multiplied by x to the b. Can we simplify this? Why, yes, of course you can. So basically the law says if you have the same base, and x is our same base, and you're multiplying, this dot represents a multiplication. I didn't use a traditional x because then I didn't want anybody to get confused why there's like 3 x's. But so the dot is the standard. convention with variables. Yeah, so x is the same base. So if you have the same base raised to an exponent, multiply, like if you have a base and then it's raised to an exponent, and then you multiply it by that same base raised to either the same exponent or a different exponent, what you can essentially do is rewrite this as x to the a plus b power, to the a plus b power. Let's take a look at an example. Let us say I have 5 to the third multiplied by I don't know, 5 to the 7th. Can I simplify it? So yeah, if you have the same base and you're multiplying, your brain should really go same base, keep the base, and then add the exponents. And kind of the way I like to remember it is that multiplication is just repeated addition. So that's how I would remember it. That you would have to add. It just makes sense that way in my brain. You can come up with other ways. The important part is that you remember it. Anyway, moving on to the next property. So, let me give myself some room over here. So, whoa. So I just moved the first one over here. I just moved the second example right over here. That's the second example. And the first example is right here. So let's move on to the third example. Let's say we have x to the y divided by x to the z. Can we simplify this? I'll give you a minute to think. And it should be coming straight out of this property. So I'm assuming you thought about it, and I did give you a hint. It should be coming out of this property, and obviously, I guess obviously, if you're multiplying something and you can add something, and like if you're multiplying and then you have to add the exponents, then wouldn't that mean that if you're dividing and you have the same base, you could subtract it? Can you do this? As you did over here because it's multiplication, then you can add. So couldn't you apply the same thing here, division, so you subtract? If you thought it that way, you would be absolutely correct. I'd give you a thumbs up. That is essentially the second property. If you're dividing something with the same base, same base, so then like x to the y over x to the z, you can simplify it as x to the y minus z power. Again, let's do an example so that our brain can really process this information. So there's two ways to simplify this. You could use the law, and that would mean 2 to the 3 minus 2, which is 2 to the first, and anything to the first power according to this property, which is common sense. Because again, the exponent tells you how many times you need to multiply your base. So if it's an exponent of 1, you just multiply it 1 time. So it would be 2. Or another way you can solve it, you can write this out as 2 times 2 times 2 over, because you're expanding it. 2 to the third says multiply the base 3 times. So 2 times 2 times 2. And over here, 2 to the second tells you multiply the base 2 times, so 2 times 2. Then you can cancel your stuff out, and you're left with 2, and you get the same thing. Same thing over there. So I've put the property, the third property right over here. And now, time for our next property. Let's assume we have x to the fifth, and we have all of that to the sixth power. Now there are a couple of ways you can approach to simplify this. You could write x to the fifth times x to the fifth times x to the fifth. I mean, but if you have something like 20 here, you're not going to want to write that out. So it's useful to know the property I'm about to show you. But as I was saying, actually, let me move this out of the way or x to the, okay, one sec, guys. Here, let me just write it out. Times x to the fifth, that's 4. X to the fifth, that's 5. X to the fifth, that's 6. So, 5 plus 5 plus 5 plus 5 plus 5 plus 5. From the multiplication property, x to the 30th. And notice, something weird, or something cool. Not weird, cool. What if you multiply these two things? You'd get x to the 30th. Maybe that's just weird for maybe 5 and 6. Let's try something else. X to the 7th to the 2nd. So x to the 7th times x to the 7th. Multiplication property, 7 plus 7, x to the 14th. Let's multiply these two. X to the 14th. So, and if you tried this with other exponent examples, you would see that this works. Obviously, if you have, like, as I said before, if this was a 20, you wouldn't want to, like, write out all of those things. So it's useful to know that if you have some base to some power, if you have x to the a, and then you have all of that to the b power, that means it'll be x to the a times b power. And for our final property, I am running out of room here. So, one sec, guys. For our fourth property, what if we have something interesting? Let's have something interesting. Tell me what x to the 0 is. Or tell me what 2 to the 0 is. Or 3 to the 0. Or 4 to the 0. I will tell you that 2 to the 0 is always going to be equal to 3 to the 0. And it'll always be equal to 4 to the 0. It'll always be equal to x to the 0. X being any base. Oh, not 10, I apologize. That should be a 0. So it could be anything, any base, any type, any base. Let's see why this is true. But let me tell you that this is all going to be equal to 1. Now let's see why that is true. Let's say we have 4 to the 4th. This is a proof of why anything to the 0 equals 1. Let's say we have 4 to the 4th over 4 to the 4th. So now we can rewrite this as 4 times 4 times 4 times 4 over over 4 times 4 times 4. 4 times 4 times 4 times 4. And we know from our recently learned property that this is also equal to 4 to the 0. And because you subtract 4 to the 4 minus 4, which is 0. And remember when I told you there's 2 ways to tackle the problem, like 2 to the 3, 2 to the 2nd, and then you write 2 times 2 times 2 over 2 times 2. Then you can cancel your stuff, and then you get 2. Or you can use your property and you get 2 to the 1st, which is equal to 2. Well, you can cancel your stuff here. There's an even number of 4s on both levels, you could say, which means it'll be 1. Now, let's talk about roots. Roots. Well, in mathematics, if you've ever noticed, everything has an opposite. Plus's opposite is minus. Multiplication's opposite is always division. Division's opposite is always multiplication. Subtraction's opposite is always plus. And likewise, exponents have an opposite too. So if you have x to the a, you can rewrite it as a root x. So this a is called the index. And this is the radical. And essentially, so the index, let's say you have square root of 9. You don't typically see the 2 when square root. So if you don't see any index here, it's blank. It's square root. So essentially it says, it's saying, what do I need to take to the second power? We're solving for our base, basically. What base do I need to raise to the second power to get to 9? And that would be 3. That would just be 3, because 3 squared is 9. You're gonna have to memorize like the roots and stuff, and you can do it with cube roots and fourth roots, and so on and so forth. And if you have a 0 root, it'll always be 1. And if you have a first root, it'll just be the same number. Then going back here, you can have a cube root, let's say it's of 27. So x to the what power is equal to 27. What's our base? 3. that'd be 3. So, congratulations if you made it to the end of this video. As always, please subscribe to the channel so I know that you appreciate the content. Yeah, that's Educational Minds Hub, over and out.